Hello everyone, this is Haiding Tian. In this video, let's learn chapter 6.5, trigonometric equations. In this video, we will go over 6 objectives. So maybe this video will be a little bit longer, or I will separate the video into 2 parts. First one, solve the trig equations. So we have learned how to find if we have sine x equals 1/2, and then we can solve the x because we have learned that in the unit circle system, the x equals 1/2. So the reference angle must be pi/6, which is 30 degrees. And this is a positive value, so it should be here or here for sine. So another angle, the reference angle here is pi/6. That means x in one full period from 0 to 2 pi, x could be pi/6. pi/6. pi/6, or x could be this angle from here to here, which is pi minus pi/6 is 5 pi/6. So how about other solutions? Because we have learned that sine x is the red curve like this, and 1/2, that means y's value is 1/2. Just like we draw a y equals 1/2, this purple line, the intersection, this intercept, that's the y equals 1/2 for the sine function. That means in one full cycle from 0 to 2 pi, we have 2 intercept, 1, 2. We can find it from the knowledge we have learned before, x equals pi/6 or x equals 5 pi/6. But how about the general solution? The general solution means all the solution. We have learned that the period for sine is 2 pi. And an angle here, the x at 2n pi. So the sine function is also equals 1/2. That means if we found one solution, x equals pi/6, I add 2n pi. The sine x is still 1/2. And the x equals 5 pi/6 plus 2n pi. We also get the same result, sine of this x plus 2n pi equals 1/2. So we can write down, so first one, we can say if x is in the domain 0 to 2 pi, 0 to 2 pi, then x equals pi/6 or x equals 5 pi/6. For the general solution, I use GS represent general solution. So x equals pi/6 plus 2n pi. Because period is 2 pi, so plus 2n pi, the sign doesn't change the value, or x equals 5 pi/6 plus 2n pi. So we can also use a bracelet to represent these two angles. For the first one, I can list the angle like this, pi/6. And another one is 5 pi/6. And for this one, we can say x such that for all x, such as put the condition for the x. X equals pi over 6 plus 2n pi. X equals pi over 6 plus 5 pi over 6 plus 2n pi. Okay, let's move on to next part to see the examples. So how about the cosecant x equals 2? Solve the x. Cosecant equals 1 over sine x. So 1 over sine equals 2. That means sine x equals 1/2. So sine x equals 1/2. Sine x equals 1/2. So this one has the same solution as the first one. Okay, let's move on to see next one. Solve 2 times tangent to x equals square root of 3 minus tangent x. Number 8 over 0 to 2 pi. So this one, we need to combine the like terms together, which is tangent x. So we can add tangent x both sides. So 2 tangent x plus tangent x equals, so this side add tangent x is just the square root of 3. So 3 times tangent x equals square root of 3, and tangent x equals square root of 3 over 3. So what is the value of x? This is a positive angle. So ASTC. The x must be here or here. And tangent x equals root 3 over 3. That means x is pi over 6 or 30 degrees. Because here is the radian, so I must use pi over 6. That means the reference angle is pi over 6. And in the third quadrant, the reference angle pi over 6. That means here from the initial side to this terminal side is pi over 6. Initial side to this terminal side is pi over 6 plus pi. So x equals pi over 6 or pi over 6 plus pi. So pi over 6 plus pi, that's 7 pi over 6. 7 pi over 6. This is the angle x in the domain 0 to 2 pi. How about the general solution over the set of real numbers? That means all the solutions. So what is the period for tangent? Period for tangent is pi. That means the general solution can be written like x equals pi over 6 plus n times pi. And how about another solution for the 7 pi over 6? Can I write down 7 pi over 6 plus n pi? Actually, look at here. If the n here, if n equals 1, I plug in the 1 in the expression pi over 6 plus pi. That's 7 pi over 6. That means this angle is included. So this angle is included in this general solution. That means there's no need for me to write down this one. So I just have one expression for the general solution. So I can erase this one. So we can also write it down like this. So for the first one, x has 2 elements. One is pi over 6. Another one is 7 pi over 6. And for this one, the general solution, x, for all x, such that x equals, this is a condition for x. Yeah, x equals pi over 6 plus n pi. Okay. Okay, let's move on to see next question. Cosine 4x equals 1/2. Solve the x. So here is not x, here is 4x. So let's see. This question, we just find the solution. Solve the x in the 0 to 2 pi because we have too many solutions in one from 0 to 2 pi. So if I use a calculator to plot the point and graph the cosine 4x, this is the blue curve is the cosine 4x, and the pink line is at y equals 1/2. So we have how many intersect? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 intercepts. So find all of these intercepts for x value. So how to solve this? So first we let 4x equals alpha because we want to make things easier. So cosine alpha equals 1/2. And cosine alpha is a positive. That means cosine must be here or here because A, S, T, C, C. So cosine here and here is positive. So I just randomly draw 2 lines. So the angle for cosine alpha equals 1/2. Angle, reference angle is pi over 3. And here is also pi over 3. Okay, so the angle alpha must be pi over 3. And from 0 to 2 pi is from initial all the way here. So the alpha is pi over 3, or from here to here, that means 2 pi minus pi over 3. So 2 pi minus 2 pi minus pi over 3 is 6 pi over 3 minus pi over 3. That's 5 pi over 3. How about the general solution for the for the alpha? So let's have a space here to find the general solution for alpha. So can I say alpha equals pi over 3? Because alpha here is cosine alpha. The period is 2 pi. That means alpha can be pi over 3 plus 2n pi. Or alpha equals 5 pi over 3 plus 2n pi. N is integer. That can be positive, -1, positive or -2, positive or -3, and so on. So this is alpha. This is not the x. The x, how to find the x? Because this one alpha also equals 4x. So x equals divided by 4, all of these, all of right-hand side and left-hand side. So this side divided by 4, that's pi over 12. So this term divided by 4 is n pi over 2. Or x equals second term divided by 4, 5 pi over 12 plus n pi over 2. N pi over 2. So this is general solution for the x. And the x, we want to find the x is in 0 to 2 pi. So we can draw a table. The first one, let's see, for the n and the x. So here is n's value. Maybe we can start from -1, 0, 1, 2. And then this side is this one, and so pi over 12 plus n pi over 2. And then 5 pi this term. 5 pi over 12 plus n pi over 2. Let's see the angle x value. So if I plug in -1 in the expression, so pi over 12 minus pi over 2. So this is a negative number. So I can't choose this one because pi over 12 minus pi over 2, plug in -1 in it. That's -5, -5 pi over 12. This is negative number. The x is not in the domain 0 to 2 pi. So I can't choose the first one. How about the second one? Let's see if I plug in -1 in this expression. So 5 pi over 12 minus pi over 2. That's still a negative number. So I can't choose this one. How about 0? If I choose 0 in it, I got pi over 12. This is 5 pi over 12. 5 pi over 12. This one works because they are all in the domain. How about this? I plug in n equals 1. So pi over 12 plus n equals 1. That's pi over 2. Pi over 2, I want to have the same denominator. That's 6 pi over 12. Because pi over 2 equals 6 pi over 12. So this is 7 pi over 12. Yes, it's in the domain. That's 7 pi over 12. How about this one? This one is 5 pi over 12 plus n equals 1 is pi over 12. Oh, pi over 2. Pi over 2 is 6 pi over 12. This one is 11 pi over 12. So 11 pi over 12. How about I plug in 2 in it? 2, n equals 2. So if I plug in n equals 2, pi over 12 plus 2 pi over 2 is pi equals 13 pi over 12. So 13 pi over 12. Yes, it's in the domain. And how about this one? Is 5 pi over 12 plus this is n equals 2. So plus pi is 17 pi over 12. 17 pi over 12. Yes, it's still in the domain. Let's try another one, 3. So if n equals 3, so pi over 12 plus 3 pi over 2. So multiply by 6 upside down. So this one is 12, 18. So this one is pi plus 18, that's 19 pi. Yes, it's still in the domain. 19 pi over 12. Well, we have so many points. And then continue, we plug in 3 here. That's 5 pi over 12 plus 3 pi over 2. That's 5 pi over 12 plus 18 pi over 12, right? And this one, 5 plus 8 is 23 pi over 12. This is 23 pi over 12. I can continue plugging 4, but when I plug in the number n equals 4, so the number here is over the domain, is more than 2 pi. So I must omit the solution here. So I have 4 solutions. So let me clean up this area. So list all the x value in the 0 to 2 pi. Okay. So first one, pi over 12. 5 pi over 12. 7 pi over 12. 11 pi over 12. 13 pi over 12. 17 pi over 12. 19 pi over 12. 23 pi over 12. So these are 8 solutions for cosine 4x equals 1/2. Let's move on to see next one. Okay. Given 2 times sine 2x equals minus square root of 3 equals 0. First one, find the general solution. Second one, solve the x on 0 to 2 pi. So here is 2x, it's not x, so we need to list a table to plug in n's value and find the solution on 0 to 2 pi. So first, let's find the general solution. So solve the sine alpha, because the first one we can let 2x or alpha equals 2x. Alpha equals 2x. So 2 times sine alpha minus square root 3 equals 0, and solve the sine alpha. So plus square root of 3 both sides. I got 2 times sine alpha equals square root of 3. Divide by 2 both sides. I got sine alpha equals square root of 3 over 2. So for the sine, it's a positive. It's here and or here. So no. It's not that good, but it's fine. So alpha here, alpha equals pi over 3. Because sine alpha equals square root of 3 over 2. That means alpha here, the reference angle is pi over 3. Or here is also reference angle is pi over 3. That means from the initial to here, the angle should be pi minus pi over 3 is 2 pi over 3. Because we got 2 pi over 3 from use all the way here pi minus pi over 3. I got the angle from the initial to the terminal. Okay. So we find the alpha. How about the general solution for the alpha, not for the x? So first find the general solution for the alpha. So alpha general solution is pi over 3 plus 2n pi, or 2 pi over 3 plus 2n pi. And alpha equals 2x. That means this is 2x. So divided by 2 for left-hand side, from left-hand side and right-hand side. So the general solution, GS, for the x, just divided by 2, all of them. So here, pi over 3 become pi over 6. Here is n pi. Or x equals this one, this expression divided by 2. This one divided by 2 is pi over 3 plus 2 pi to n pi over 2. That's n pi. This is a general solution. I can write it down like this. X such that this one is such that equals pi over 6 plus n pi. x equals pi over 3 plus n pi. Where number 2, we are looking for the solution on the interval 0 to 2 pi. So I can list a table here. The first one is n, and second term is the general solution pi over 6 plus n pi. Then another one is pi over 3 plus n pi. So when n equals, let's try, if n equals -1, so pi over 6 minus negative pi is a negative number. And this one minus pi is also a negative number. So I can't start from n equals -1. So I can try n equals 0. So n is equals 0. The first x equals pi over 6. Second is pi over 3. How about n equals 1? If n equals 1, pi over 6 plus pi, that's 7 pi over 6. Yes, this one is in the domain 0 to 2 pi. So if n equals 1, so pi over 3 plus pi is 4 pi over 3. It's also in the interval 0 to 2 pi. Yes, these two answer is good. So how about 2? So n equals 2. So 6 pi plus 2 pi, pi over 3 plus 2 pi is more than interval 0 to 2 pi. So I don't choose these two. That means I have 4 solutions, 4 angles. So pi over 6, pi over 3, 7 pi over 6, 4 pi over 3. And sometimes if you think we want to order them from the small angle to the big angle, so you compare these two angles. So this one is smaller than 7 pi over 6. I can switch the position of these two. That's pi over 6, 7 pi over 6, pi over 3, 4 pi over 3. Because this, oh, am I correct? Oh, I don't need to move the position because pi over 3 is smaller than 7 pi over 6. So I made a mistake. So there's no use to rearrange them. So just to keep these 4 angles. Sometimes the angle we list, so maybe, for example, this angle is smaller than this one. We can switch the position to make sure from the small angle to the big angle. But this question, so they just follow the order from small to the big. So we don't need to reorder them. So that's the solution for this one. Let's move on. Okay. Yeah, no problem. This one, given -1 plus sine x over 2 equals 0. So this question, the sine is not the x, it's x over 2. Let's see how to solve this one. Number A, so general solution. So always make sure this one is the, to convert to the x over 2 equals alpha and solve the sine alpha. So let alpha equals x over 2. So -1 plus sine alpha equals 0. So sine alpha equals 1 because I need to add a 1 both sides. So sine alpha equals 1. In the unit circle, so we know every point on the unit circle is cosine x or cosine alpha, sine alpha. So cosine alpha is x value. Sine alpha is y's value. This is y, this is x on the xy plane. So sine alpha equals 1. That means y's value equals 1. That means y's value from here to here is 1. Yes, that means the angle is from here to here. That means alpha equals pi over 2. So this is the alpha. And what's the general solution for alpha? Alpha equals pi over 2 plus 2n pi. And how about the x? So this is x over 2. So the x equals all of them multiplied by 2. That's pi plus 4n pi. So I can write it down like this. X such that x equals pi plus 4n pi. This is a general solution. How about the solution on 0 to 2 pi? So I can list the table for n. So pi plus 4n pi. So how about n equals -1? Let's try. For n equals -1 is minus 4 pi. Pi minus 4 pi is -3 pi. It's not in the domain here, so I don't choose a solution here. How about 0? If I put 0 here, I got pi. Yes, it's in this domain. How about the positive one? If I plug in y equals +1, pi plus 4 pi, that's 5 pi, is bigger than 2 pi. So I don't choose that. So this is the only solution for the x on the interval 0 to 2 pi. Okay, let's move on. For this one, the angle becomes x minus pi over 3. So let's see the general solution. The first step is also let so let alpha equals x minus pi over 3. So sine alpha equals negative square root of 2 over 2. So sine is a negative angle. So ASTC. So alpha must be in third and fourth quadrant. So the reference angle, because this is square root of 2 over 2, that means reference angle here is pi over 4 or 45 degrees. Here is also pi over 4. So how about the alpha? Alpha is from here to here or here to here. That means alpha equals, if from initial to this terminal, that's pi plus pi over 4, that's 5 pi over 4. Or alpha equals from here all the way here. That means 2 pi minus pi over 4. That's 2 pi minus pi over 4. That's 8 pi minus 8 pi over 4 minus pi over 4. That's 7 pi over 4. Okay, this is a solution for alpha. How about the one full cycle? Oh, sorry, the general solution for alpha. So alpha is 5 pi over 4 plus 2n pi. Because this is a sine alpha, we need to plus 2n pi. Or 7 pi plus 4 plus 2n pi. How about the x? Alpha equals x minus pi over 3. So x minus pi over 3 equals, so just copy down these two terms. 5 pi over 4 plus 2n pi, or 7 pi, 7 pi over 4 plus 2n pi. And then we need to isolate the x. So add pi over 3 to these two terms. X equals, so 5 pi over 4 plus pi over 3. they need the same denominator, 12. And then 5 times 3, 15 pi plus 4 pi. That's 19 pi over 12 plus 2n pi. And how about this term? Plus pi over 3. So 7 pi over 4 plus pi over 3. The same denominator is 12. 7 times 3 is 21 pi. And this one is plus 4 pi. That's 25 pi over 12 plus 2n pi. This is a general solution for the x. I can write it down like this. X equals 19 pi over 12 plus 2n pi. N is always an integer. X equals 25 pi over 12 plus 2n pi. How about the solution on 0 to 2 pi? So number B, we can list a table. Here is n. The first one, let's see, is 19 pi over 12 plus 2n pi. Another one is 25 pi over 12 plus 2n pi. How about n equals -1? So 19 pi over 12, for example, -1, minus 2 pi. 2 pi is 24 pi over 12, because I just plug in -1 in the 2n pi. So this one is a negative angle because 19 pi minus 24 pi, that's -5 pi over 12. So I can't choose this one because the x should be a positive angle. And how about this one? This one, 25 pi minus 2 pi, that's pi over 12, because 25 pi over 12 minus 2, because here is -1 minus 2 pi. 2 pi equals 24 pi, 24 pi over 12. 24 pi over 12. So this one minus this one is pi over 12. Okay, how about 0? If I put 0 in here, is 19 pi over 12. If I put 0 here, I got 25 pi over 12. And 25 pi is over 12 is more than 2 pi. I can't choose this one. That means I have two angles for x. That's pi over 12 and 19 pi over 12. Okay, that's the solution for this one. Let's move on. Solve the higher degree. So this part, we need to use the algebra we have learned before. So this one, just imagine that sine x equals a. So this one, I can write it down like 2a squared plus 7a minus 4. Use a crisscross. So 2 equals 2 times 1. 4 equals 1 times 4. And this is a negative sign. I put it here or here. See, I should put it here because I need to cross multiply. And then, so 2 times 4 is 8. 8 minus 1 is 7. So I got 7 here. I can write it down like 2 times sine x, or you can use a. It doesn't matter. So sine x minus 1 times sine x plus 4 equals 0. That means this expression equals 0, or this one equals 0. That means 2 times sine x minus 1 equals 0. Equals 0, or sine x plus 4 equals 0. and solve the sine x. Sine x equals 1/2, or sine x equals -4. Can I choose sine x equals -4? We can't choose sine x equals -4 because we have learned the sine x. I can continue to draw. The maximum is 1, minimum is -1. So I have nowhere to draw more graph in this area, because the y's value if equals -4, the graph must be here. So this one is not in the range of sine x. So we need to delete it or omit it. So put an x here. So if we are looking for sine x equals 1/2, sine x is a positive. That means here or here. The reference angle for sine x equals 1/2. That's pi over 6. X equals pi over 6. How about in this quadrant? So reference angle is pi over 6 from the terminal side to, from the initial side to the terminal side equals pi minus pi over 6. So another solution is 5 pi over 6 from here to here. That's pi minus pi over 6. That's 5 pi over 6. This is solution in 0 to 2 pi. Oh, it just let us find the solution on 0 to 2 pi. So these are two solutions. So pi over 6, 5 pi over 6. Okay, let's see next one. Solve the x on 0 to 2 pi, or the same thing. So this is 2 times cosine squared plus square root of 3 cosine x minus 3. So midterm is square root of 3, and we have learned that 3 equals square root of 3 times square root of 3. So do the cross multiplication, crisscross, 1, 2, because 2 equals 1, 2. And the -3 equals square root of 3 times square root of 3. And where I should put the negative sign. Here is a positive square root of 3. That means I need to have negative sign here because cross multiply. 1 times negative square root of 3. 2 times positive square root of 3. Square root of 3 plus 2 times square root of 3. This one equals square root of 3. This is a coefficient of cosine x. That means this term equals cosine x plus square root of 3 times 2 times cosine x minus square root of 3 equals 0. This term equals 0, or this term equals 0. So cosine x plus square root of 3 equals 0, or 2 times cosine x minus square root of 3 equals 0. And then cosine x equals square root of 3, or cosine x equals square root of 3 over 2. And can we choose this one? No, because for the cosine, what does the cosine look like? I can continue to draw the graph. The maximum is 1. The minimum is -1. The square root of 3, negative square root of 3, it's about -1.72. -1.732. So I can't choose this one because cosine equals -3, the x is impossible because the minimum is -1. There's no graph at y equals -3 here. So I can't choose this one. So cosine x equals square root of 3 over 2. So for cosine equals a positive value, cosine be here or here, ASTC. So what is the x? So the x must be equal pi over 6. Because for cosine pi over 6 equals square root of 3 over 2. So reference angle is pi over 6. Also in the fourth quadrant is still pi over 6. So from the initial to here is pi over 6. From initial to this terminal is 2 pi minus pi over 6. So another value is 2 pi minus pi over 6. That's 11 pi over 6. So these are two solutions for this one. I can write it down like this. Pi over 6, 11 pi over 6. Okay, that's the solution for this question. Let's move on to see next one. So tangent x times sine x squared equals tangent x. So can I divide it by tangent x both sides? No, because if we do the multiplication or division, we will lose some solutions, miss some solutions. So we better to just do the addition or subtraction to keep all the solutions there. So I can move this term to the left-hand side. So tangent x times sine x squared minus tangent x equals 0. And then pull out the tangent x equals sine x squared minus 1. Do you still remember a squared minus b squared equals a plus b, a minus b? So this is a, this is b. So tangent x equals sine x plus 1 sine x minus 1 equals 0. That means tangent x equals 0, or 0, or this one equals 0, or this one equals 0. So, or sine x equals 0. Oh, sorry, sine x plus 1 equals 0. Plus 1 equals 0, or sine x equals 1, because, oh, I need to do the step-by-step. Minus 1 equals 0. Okay, let's solve this. For tangent x equals sine x over cosine x. That means cosine can't be 0, but the sine x is 0 because the numerator equals 0, so the fraction equals 0. That means sine x equals 0. Where is the sine x equals 0? We know all the point on the unit circle equals, cosine goes first, sine second. That means when sine equals 0 means y's value is 0. Where is y equals 0? In these 2 points. That means x equals 0. This one, x equals pi. So this is solution for tangent x equals 0. How about this? So sine x plus 1 equals 0. That's sine x equals -1. And on the unit circle, Sine is the y's value. Y equals -1. So the angle, the point is here. From initial to terminal here is 3 pi over 2. So x equals 3 pi over 2. So remember here, when you got here, so is that means x value equals 0? Yes, the x is 0. And that means cosine x equals 0. Cosine 3 pi over 2 is 0. So I just put the information here. And how about the sine x minus 1 equals 0? That means sine x equals 1. So on the graph, that means cosine equals 1. Cosine equals 1. Oh, sorry. I'm sorry. Sine x equals 1. That means y equals 1. So y equals 1. That means the point is here. So it's from here to here. That means x equals pi over 2. And how about the point here? How about the cosine x? Cosine x, that means what is the x value? Sorry, I mean the x here, that's the cosine x, sine x. So cosine pi over 2 here, that's 0. Okay, so first one, you must satisfy cosine is not equal 0. That means x equals 3 pi over 2, make the cosine equal 0. For the x equals pi over 2, the cosine is also 0. That means we can't choose these two x value because we must satisfy the condition for the cosine is not equal 0. That means the solution for this one, make a short line. So the solution we can only choose is x equals 0 and x equals pi. That means we have only two solutions, which is 0 and pi. So let's move on to see part 4. Use identities to prove the trig equations. This one, solve the x on the 0 to 2 pi. Secant x squared minus tangent x equals 1. So this one has secant and tangent. So we can't make it easier if we don't use the trig identities. So let's use the trig identities. That is tangent square root of x plus 1 equals secant x squared. So secant x squared equals this term. I just plug in this one in the expression. So tangent x squared plus 1 minus tangent x equals 1. And then 1 and 1 cancelled out because I can minus 1 both sides. Right now I have tangent x squared minus tangent x equals 0. Pull out the tangent. Tangent x times tangent x minus 1 equals 0. So I have two conditions. One is tangent x equals 0 or tangent x equals 1. So for tangent x equals 0, we have learned that tangent x equals sine x over cosine x. So if this term equals 0, sine is 0. So on the unit circle, 1 is sine 0. So every point here is cosine x, sine x. So this one is 0. That means all the y's value is 0. That means it's here and here. That means x equals 0 or I draw a line. x equals pi. Because here or here. How about the tangent x equals 1? So let's draw a unit circle. We have learned that if tangent x equals 1, the reference angle is pi over 4. So x equals pi over 4. Since this is positive, ASTC, the tangent here is also positive. That means reference angle here is also pi over 4. So the angle from here to this terminal is pi plus pi over 4. That's 5 pi over 4. So we have 4 solutions for this question. So can we choose all of them? Yes, for sure, because we didn't do the multiplication or a division. So all the solutions should be here. I can use, I can list them here. 0, and then next term is pi over 4, because pi over 4 is smaller than pi. And then pi. And that next one is 5 pi over 4. Okay, let's move on to see next one. Solve the x on the interval 0 to 2 pi. The expression is 2 times tangent x equals secant x. So this one, we have learned this tangent equals sine over cosine. So I just plug in the sine x over cosine x equals secant equals 1 over cosine x. They both have the same denominator. I can combine them together. 2 times, this is not good too. 2 times sine x over cosine x minus 1 over cosine x equals 0. So same denominator, cosine x. 2 sine x minus 1 equals 0. And then if this fraction equals 0, denominator cannot be 0. That means only the top equals 0. That means 2 sine x minus 1 equals 0. Sine x equals 1/2. And then we have learned sine is positive, it's here and here. The reference angle for sine x equals 1/2 is pi over 6. So pi over 6. X equals pi over 6, or x equals, from here to here is 5 pi over 6. And also we have learned that cosine pi over 6 and cosine 5 pi over 6 is not 0. So satisfy the condition for the cosine is not 0. That means this is a solution for x. That's pi over 6 or 5 pi over 6. Okay, let's move on to see next one. Solve the x on the interval 0 to 2 pi. Cosine 3x plus cosine x equals 0. For this one, we can use the sum to product formula. So cosine equals 2 times cosine. So this one, cosine 3x plus cosine x equals 0 equals 2 times cosine 3x plus x times cosine 3x minus x equals 0. So 2 times cosine, this term is 4x over 2. That's 2x times cosine 3x minus x is 2x. 2x over 2 is x equals 0. That means cosine 2x equals 0. Oh, that's not a good 0. Or cosine x equals 0. We can solve both of them. So for cosine 2x, we have learned that this is 2x. I can just let alpha equals 2x. And cosine alpha equals 0 on the unit circle. So all the points, they are all cosine x or cosine alpha. Sine alpha. So if cosine alpha is 0, this term is 0. That means for the x equals 0, 0, that means these 2 points make the x is 0. So alpha equals pi over 2, or alpha equals 3 pi over 2. General solution for alpha equals pi over 2 plus 2n pi, because cosine alpha's period is 2 pi. So another one is 3 pi over 2 plus 2n pi. This is alpha, this is not 2x. Oh, sorry, this is not x, this is 2x. So the x, since alpha is 2x, so x equals all of these terms divided by 2 equals pi over 4 plus 2, oh, sorry, divided by 2. So this must be 2, must be n pi. N pi. And this one is 3 pi over 4 plus n pi. And the x is in 0 to 2 pi. I can also draw the table. Here is n. Here is pi over 4 plus n pi. Don't have too much space. 3 pi over 4 plus n pi. Let's see if n is -1. So -1 make the angle negative. So try 0. N equals 0. Pi over 4. 3 pi over 4. How about n equals 1? So pi over 4 plus pi, that's 5 pi over 4. This is also a good one. And 3 pi over 4 plus pi, that's 7 pi over 4. Is that correct? Yes. And how about 2? 2, I can't choose that because 4 pi plus 2 pi is more than 2 pi. So also this one is greater than 2 pi. So I have 4 solutions. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I have 4 solutions. How about another side? So for cosine equals 0, so cosine, every point on the unit circle is cosine x sine x. So cosine equals 0, that means is here and here. That means x equals pi over 2 or x equals 3 pi over 2, right? And actually, we don't need to add 2n pi for the general solution because this is just a one full cycle from 0 to 2 pi because this is just a basic form. So if you think I need to do the step by step, you do the general solution. So GS for x equals pi over 2 plus 2n pi. X equals 3 pi over 2 plus 2n pi. So n equals -1, make the angle negative. N equals 0, so it's pi over 2, 3 pi over 2. N equals 1, it's more than 2 pi, more than 2 pi. That means we have 2 solutions for x in the 0 to 2 pi. That's pi over 2 and 3 pi over 2. So these solutions, they all satisfied this one. That means I need to add them together. So the okay, add them together. That means the final result must be pi over 4, and then should be this term because this one is smaller than 3 pi over 4. So pi over 2, 3 pi over 4, and 5 pi over 4. This one is 3 pi over 2. Seven pi over 4. This is a final solution. Let's see. Okay, let's move on to next one. This very long video. Solve the x on interval 0 to 2 pi. Sine x plus 1 equals cosine x. This one is a hard one. Oh, this one is hard one. We need to square both sides. Q-U-A-R-E. Square both sides. Okay, so sine x plus 1 squared equals cosine x squared. And then sine x squared plus 2 sine x plus 1 equals cosine x. So I want to just keep one trig function. I just want to keep sine. I need to cancel out the cosine. And I have learned that 1 equals sine x squared plus cosine x squared. So sine x squared plus 2 sine x plus sine x squared plus cosine x squared equals cosine x squared, because 1 equals this. And then minus cosine x squared both sides. I got this one equals 0, right? So this term plus this term is 2 times sine x squared plus 2 sine x equals 0. And then pull out the coefficient 2 and also pull out the sine x. 2 times sine x times sine x plus 1 equals 0. That means sine x equals 0 or sine x plus 1 equals 0. So I can solve them separately. So sine equals 0. So every point is cosine alpha sine alpha or cosine x. Here is x, x. So if I want sine x is 0, that means y's value is 0, because this is y's value. Y's value is 0. That means x equals 0 or x equals pi. And since this is x, we don't need to add the general solution something, because it's in the 0 to 2 pi. So these two answers, we need to keep both of them. And then how about sine x plus 1 equals 0? Sine x equals -1 on the unit circle. So the y's value, cosine x, sine x. That means this term is -1. So -1, that means y's value -1 is here. That means from here to here, x equals 3 pi over 2. So we find 3 angles. Since we, at the beginning, we squared both sides. So we do something for the equation, because before we learned that we better not do the multiplication or division, and right now we squared it, so I can't guarantee all the solution should be is the solution for the original function, original equation. So let's try if all these three satisfied this one. So for x equals 0, so sine 0 is 0, 0 plus 1 is 1. So 1 is our left-hand side. How about the right-hand side? Cosine 0, I have learned that cosine 0 is 1 because cosine 0, the first point is a maximum, that's 1. So 1 equals 1, yeah, x equals 0 is a solution. How about x equals equals pi. So x equals pi. Let's erase this. So x equals pi. So sine pi, what is sine pi? Sine pi is 0. Why? Because let's see this. So sine pi is here because pi is here. Sine pi, that's y's value, is 0. That's 0 plus 1 is 1. How about the cosine? Cosine value. Cosine is x value, right? So cosine pi is here. The x, this term must be negative 1. 1 equals negative 1? No. This one, this solution, I can't choose. And how about x equals 3 pi over 2? 3 pi over 2. So let's see. 3 pi over 2 is here, right? So the point here is 0, negative 1. So let's see. Sine is negative 1 at 3 pi over 2. Okay, it's negative 1 plus 1 equals cosine x. Cosine x is this term, is 0. So negative 1 plus 1 is 0, yes. So for this one, solution only have two. One is x equals 0, another one is 3 pi over 2. Okay, I box the solution. So next one, solve the x on 0 to 2 pi. Tangent x equals 3. Tangent x equals 3. This one, we can't use special angle to solve it. We can use the our calculator to find the x. And it's on 0 to 2 pi. So tangent x is a positive number, ASTC. So it's here or here. So it's here or here. But our calculator only gave our answer for this angle. Why? Because the inverse tangent only have the value from, let's try this color. It's better. Inverse tangent only gave us the value from here to here or here to here. If in fourth quadrant is negative angle, in the first quadrant is positive angle. That means this is positive. They only gave us the angle here. So let's see. After we get the angle for this one, so is this angle, reference angle equals this one? Yes. That means first we find one angle for x, and then we find the angle for this one. From initial to this terminal. That means this angle plus pi. So let's see, what is the inverse tangent 3? Oh, I need to share the screen. New share. I need to share everything. Share. Okay, I hope you can see the calculator on. Okay, so inverse tangent. Second tangent 3. Oh, I forgot to see the mode of the calculator. I must have the radian. Yes, it's radian. Second mode, quit. So let's see, because look at here. Solve the x on the 0 to 2 pi. This is a radian. That means we need to set up our calculator to the radian form. and then hit enter. So the x equals 1.249. So x equals 1.249, for example, approximately. If we keep 3 decimals, and this is the angle here. How about the angle from here to here? That means I need to add a pi here. So, or x equals 1.249 plus pi. Maybe plus 1.249 plus 3.142. It's about let me see, 193, yes, 4, no, yes, 4, so 4, oh, I use my calculator. So this number plus 3.142, yeah, 4.391. So these are two solutions. So I can list them like this: 1.249. Another one is 4.391 if I keep 3 decimals. This is number A. How about number B? Number B, for the sign is negative. For sign is negative is here and here because we have learned A, S, T, C. So must be here or here for one full cycle, from 0 to 2 pi. And our calculator won't give us the angle here for this angle here, because our calculator for the inverse sine only be here. That means if our calculator provide us the angle is a negative angle is from here to here for sine x equals negative 0.8. So let's see the reference angle. We put RF. I can't say RF because RF is a positive acute angle. So I just say alpha. So for alpha from here to here, the calculator gave the angle alpha for us. Let's see the inverse. I'd better. Okay, so alpha equals the inverse sine negative 0.8. So let's use calculator to see. Clear? So inverse sine negative 0.8, close the parentheses, enter. So the alpha, I didn't see the answer. The negative 0.927. It's about negative 0.927. Is that correct? I think so. Okay. This is the alpha here. So how about the positive alpha? The positive alpha is here, right? It's alpha. Oh, I should use beta or alpha, absolute value of alpha. Or I use reference angle. So the reference angle for alpha is in first quadrant is the same like the absolute value of alpha. That means, what's the meaning? Why I'm looking for the reference angle? Because we are looking for the angle here. Let me use another color. This one better? Okay, we are looking for this angle and this angle. So we need to find from initial to here, initial to this terminal. That means if I know the reference angle, this angle or this angle must be positive, RF is 0.927 positive. So I can find the angle here, right? Let's see, what is the angle from here to here? Is that a pi plus the reference angle 0.927? Yes. So the x, now I must write x. The x equals pi plus reference angle 0.927, or from here to here, that means 2 pi minus 0.927. So I can plug in the pi's value. If I keep 3 decimals, that's 3.142. So x, just plug in pi equals 3.142 in it. So is C, it's 9, 6, 0, 4, and this one. Oh, I like my calculator. So let's use a calculator. So 3.142 times 2 minus 0.927. I got 5.357. Okay, this is a solution for this question. Okay, let's move on. Since I just plug in, I hope there's no mistake. If there's some mistake, maybe it's typo. Let's see. Yeah. Okay, let's move on to see next one. Oh, this is the application. The monthly sales of winter coats. So please pause the video. Actually, we have 2 ways to pause the video and read the question. Actually, we have 2 ways to solve it. Before, we have learned how to graph the cosine function. You can graph the cosine function, find the maximum, minimum, find the range domain, and solve it. But for this question, we have learned something new. Okay, please pause the video and read the question. So first, write the range of the function in the integral notation. We have learned the range. We can write it down like y, but here is st. So I can use st. S of t is greater than or equal to the d. This is d. Because before cosine is like this, and then we move it up 5,000 unit, go to the up, go to the top. It's not like this. For example, so this line become 5,000. That means based on 5,000, the maximum need to be here, 5,000, the d plus the d plus the maximum 2,000, a. Put a here, absolute value of a. So I got the maximum point and the minimum point based on the 5,000 minus the absolute value of a. If you don't understand, you just memorize this formula. Okay, number A So plug in the A and D's value. So the S of T, the range is between D is 5,000 minus 200, absolute value of 2,000, that's 2,000. And then the maximum is D plus absolute value of A is 5,000 plus 2,000. So I can rewrite it. I rewrite the range. That means the range is between 3,000 to 7,000. This is a range for the function, this interval. Sorry, for this function. And number B, during which months are sales at their maximum, sorry, maximum. What's the meaning of this? That means the expression. So the function here approaches the maximum. That means S of T equals maximum. What's the maximum? Maximum is the maximum range, maximum Y's value for the function. That's 7,000. That means when this one equals 7,000, what is T's value? We feel very familiar because we just learned this. Number B. So set all of this equals maximum 7,000. So 2,000 cosine pi over 6t plus pi over 6 plus 5,000 equals 7,000. So 2 minus 1,000 here. I'd like to divide it by 1,000. All of the right hand side and left hand side. I can simplify this. It's 2 times cosine pi over 6t plus pi over 6t plus 5 equals 7. Since it's getting easier, so isolate this term. So minus 5 both sides. 2 times cosine pi over 6t plus pi over 6 equals 7 minus 5 is 2. Okay, divided by 2, both sides, cosine pi over 6t plus pi over 6 equals 1. So let this one equals alpha. Alpha equals pi over 6t plus pi over 6. So cosine alpha equals 1. And if I draw a unit circle, this is not beautiful. Okay, if I have a unit circle, and then all the point on here is cosine alpha, sine alpha. So when this term is 1, that means x value is 1. X value is 1. From here to here, x is 1, right? So the alpha is 0 or 2 pi. I don't know because this question, it didn't say something is between 0 to 2 pi. It doesn't have in the interval 0 to 2 pi, right? So we don't have this. That means I can say alpha equals 0 to 2 or 2 pi. And that means this one equals 0 or 2 pi, right? So pi over 6t equals 0 or, oh, sorry, I missed that plus pi over 6. Okay. Plus pi over 6 equals 0 or pi over 6t plus pi over 6 equals 2 pi. Let's solve this. So pi over 6 plus times t plus pi over 6. So minus pi over 6 both sides. So pi over 6 times t equals negative pi over 6. That means t equals negative 1. How about this one? If I solve this, minus pi over 6 both sides. Pi over 6t equals 2 pi minus pi over 6 is 11 pi over 6. And then multiply 6 by 6 and divide by 6, t equals 11. So I have two solutions. So go back to see the question. During which month t is between 0 to 12? And here we solve the t equal -1. That means I can't choose this one. We only choose t equals 11. So 11 is which month? Is November, right? So no, then N-O-V-E-M-B-E-R, November. So this is November. Oh, I have no space for number C and number D. Let's see. Let's just make a space for number C. Question C. What does the question C looking for? During which month the sales at their minimum? That means all of these expression equals minimum. Minimum is 3,000. So I just borrow this part and equals 3,000. So 2,000 cosine pi over 6t plus pi over 6 plus 5,000 equals 3,000. It's equal sign. Okay, divided by 1,000 for 3 terms. I got 2 times cosine pi over 6t plus pi over 6 plus 5 equals 3. And divided, oh, sorry, minus 5 both sides. I got 2 times cosine pi over 6t plus pi over 6 equals -2. So cosine pi over 6t plus pi over 6t equals -1. And since we have used the alpha here, can use beta equals pi over 6t plus pi over 6. So cosine beta equals -1. So cosine at which position is -1? So cosine is -1. That means x is -1. X is -1 is here. So beta equals pi. So if beta equals pi, all of this equals pi. So pi over 6t plus pi over 6 equals pi. And let's find the t. So pi over 6t equals pi minus pi over 6 is 5 pi over 6. And t equals 5. So 5. So when is t equals 5? Let's see. Is that right? No. Why I have different one? Let's see. I got one in previous slides. Why I don't have the same one? Let's see. Okay, this is 3 minus 5 is -2. So everything good. -1, very good. Beta equals pi over 6 times t plus pi over 6. Cosine beta is -1. Yeah, perfect. So beta is pi. Yes, it's from here to here is pi. And this one is pi. Pi minus pi over 6 is 5 pi over 6. I think there's no mistake. So May, for t equals 5, the month should be May. So this is looking for which month our sales at their minimum. I think that's the May. So I make a mistake because I put 1 here. So I don't know why I got t equals 1. Maybe some typos, but now we didn't make mistake. So number C, t equals 5. So what is number D? In which month are the sale is 6,000? Oh, maybe that's the answer for number D, not number C. Oh, I don't have space. Let's see where I can find a space. Number D. It's so messy here. Can I write here? No. Okay. So just make a space here. Number D. Number D means which months are the sale equals 6,000. That means looking for the T, and all of this function equals 6,000. So that means 2 times 2,000 times cosine. Okay, make everything small, save some space. So 2,000 times cosine pi over 6t plus pi over 6 plus 5,000 equals 6,000 divided by 1,000 each terms. That means 2 times cosine pi over 6 pi over 6t plus pi over 6 plus 2 equals 6. Here is 5. So minus 5 both sides. So 2 times cosine pi over 6t plus pi over 6 equals 6 minus 5 is 1. So cosine pi over 6 times t plus pi over 6 equals 1, equals 1/2. So cosine, so let's this one equals alpha. So cosine alpha equals 1/2. So cosine, what degree equals 1/2? That's pi over 3. So alpha equals pi over 3. And also we can equal a number, an angle here, or is, what is that? Is 2 pi minus pi over 3 is 5 pi over 3. So we have 2 angles for alpha. And this one, so if pi over 6t plus pi over 6 equals pi over 3, what is t? So let's see. Pi over 3 minus pi over 6, that's pi over 6. And then t equals 1. Oh, how about or pi over 6t plus pi over 6 equals 5 pi over 3. So this one equals 10 pi minus pi is 9 pi over 3. So, oh, I hate it. I don't have space. So pi over 6t equals 9 pi over 3. That's 3 pi. I don't know. Let's do that step by step. So if you have scratch paper, find the result of this and find the t. Let's see. Borrow a space here. Okay, that's 5 pi over 3 minus pi over 6. That's bottom 6. 10 pi minus 10 pi minus pi. That's 9 pi. Okay, bottom 6 is 3 pi over 2. 3 pi over 2 multiply by 6. 6, that's 3. That's 9 pi divided by pi is 9. So the t could be 9. T also could be 9. Oh, so too many things here. So we should have two answers. The T is equals 1, that means January. And the T equals 9 is September. I hope there's no mistake for this one. If I have mistake, I will correct the video, and I also need to correct the notes. I hope there's no mistake if I don't have typo. Okay, so tired. And let's move on to the last slides, last page. I still want to check if 9 is good. So if I plug in 9 in the expression, so it's 9, 6 is 3 pi over, just to put 9 here, 9 pi over 6. 9 pi plus 1 is 10 pi. 10 pi over 6 is 5 pi over 3. Oh, perfect. So that should be January and September. Okay, the last one, we're gonna win. Use a calculator to solve the x squared minus sine 2x minus 2. You can pause the video and read the description here. So first, I will use the calculator to find the graph for f of x equals x squared minus sine x sine 2x, and another function is y equals 2. Because look at the image, the graph here. The blue line is the function x squared minus sine 2x, and the red line is 2. We're looking for the intersection for the x value. So I want to find the x value for this intercept. X value for this intercept. How to use the calculator to find these two intercept. So pull out your calculator and then turn it on, clear. And here, click this button, and then for y1 is plug in your, so input your first function, which is x squared minus sine 2x. So x squared, here is x squared is here, just click x squared minus, oh, this is not minus, it's negative, so delete that. So minus sine 2x, close the parentheses. And then next function is y equals 2. And then we can graph. Here is graph, heat graph. Oh, it's graphing. And next step, I want to find the intersection of these two, and the intersections x value. So the x value, we can click second trace. And then number 5 is intersect. So click number 5. And then what's the meaning? How to find the intersect? So first you choose a point on the blue curve, and then choose a point at the red curve. That means the first one, they ask you first curve. Yes, because the cursor is on the blue curve. So I hit enter. And then the second curve is on the red curve. Is this your second curve? Yes, of course. And then they ask you, guess the intersection. So I'm guessing the first intersection. Look at this cursor. So I guess it's very close to this area, but this is not your accurate answer, just a guess for you, because I guess the first intersect is here. So I click enter. The calculator will provide you a accurate one. That is negative 1.082117. So the intersection is here. So you can list your the first x value here and round the solutions to 4 decimals. It rounds to 4 decimals. So we are looking for the second intersect. So the same way, so I click second, trace. Number 5 is looking for intersect. So I'd like to choose, click this button. And then, so because I want to be accurate, I want to move all the points on the right-hand side. So any point is good on the blue curve. So even it's on the beginning side, it's okay. So I can click enter because the cursor is on the first blue curve. So hit enter. And then it's asking you second curve is your right function. Yes, I hit enter, or I can move my cursor left and right. It doesn't matter. So hit enter. Guess, I'm guessing. So click this button because I want to move my cursor to the intersect, close to the intersect. So maybe it's here. I hit enter. So it will provide us an accurate intersect, which is 1.47800092 and round to 4 decimal places. I got 1.4780. So that's the way you use a calculator to approximate your x, the angle x. So that's all about chapter 6.5. That's a long one. It's a long lecture. I hope you learned something. And if you have any question, please let me know. Okay, have a good one.